Capacitors are able to hold charge, and we often use them to help store charge for emergency or temporary use. As I mentioned before, all capacitors can be described by this equation. However, in a complicated circuit, this equation might not be immediately useful. Luckily, we've derived relationships between capacitors in series and in parallel to help reduce them to simpler circuits. For capacitors in series, they must hold the same charge. To reduce a bunch of capacitors in series to a simpler circuit, we use the following relationship. Notice that this goes on for as many that you have in series. For capacitors in parallel, they must have the same potential difference. To figure out the equivalent capacitance of capacitors in parallel, simply add up the capacitance of each individual capacitor, onward to however many capacitors you have. Just like resistors, you may have a very complicated circuit diagram. Using these rules, you can break down each capacitor into simpler representatives. You may also want to look at the energy stored in different capacitors in a complicated circuit, in which case you'll want to remember Q equals C times change in V and these three energy equations.